It's my great pleasure now to introduce Professor Peter Stiles from Keele University. And he's going to give us a layman's guide to exploration, extraction processes, and supplier equipment. Professor Peter Stiles, Peter.
Far be it from me to disagree with Bill, because he's much bigger and tougher than me, but some of us are from the northeast, if you hadn't noticed. However, kindred spirits across the Pennines. Okay, I'm going to tell you a little bit about shale gas. There's a lot can be said about it. I'm going to probably skim over many of it. I'll put this first picture up because in actual fact it's mostly ministers and BBC presenters who stand there on Palace Green in front of the Palace of Westminster. But shale gas got me interviewed by there, so I'm actually very grateful. And I see you've got all of these things. Presumably if you don't like my talk, you'll beam me up, Scotty, and I'll vanish into another dimension. So shale gas, what is it? Where is it? How can we get it? And when? So a few introductory comments. I'll then tell you about shale and shale gas. I'll then tell you about the processes which are required to get that gas out, what the chemicals are used. I'll deal with some of the environmental issues, and I'll wrap up and leave it to you businessmen to tell me how this is going to be done to our own best advantage. So what is shale, first of all? Well, in actual fact, geologists around the world have spent most of their lifetimes ignoring shales because they're actually quite uninteresting-looking grey rocks. If you drive across mid-Wales, you drive mostly through Cambrian, Silurian, Ordovician shales, and we drive very quickly through those. We've usually been much more interested in the pretty rocks, the granites, the sandstones, etc. But in actual fact, we should have been a lot more attentive because shales are actually really very important to us. And essentially, they're sediments laid down in oceans and lakes from very, very fine sediment together with organic material. Now, during the Carboniferous period, the coal-bearing period and before, there was an ocean which stretched from west of Ireland to the Urals. Okay? And in most of that ocean, these sediments were being deposited. And it was over a large period of time across Europe, from the Cambrian, which is about 500 million years ago, to the Cretaceous, and very, very extensively. Now, the interesting thing about shales is that all oil and gas, with the exception of a bit which comes from coal, is generated in those shales. For years, we've been looking for oil and gas in special kinds of geometrical features, and I'll show you in a minute. But in actual fact, below those is the actual source of all of the oil and gas. And terminology is developed, which is not very helpful, which says that conventional oil and gas is oil and gas which has leaked out of these shales, probably several hundred million years ago, has migrated. Much of it was lost and escaped to the environment. We need to remember that. And a little bit of it was trapped. But a great deal of it still remains there in those shales. Unconventional resources are the oil and gas that remains in those shales. There's a little picture of it there. We can see. You can still hear me. I'm very loud. Can you hear me at the back? The grey is the source rocks, the shales. Some of it comes out and is trapped through various geological features. They're very hard to find. The oil industry spends billions chasing down these oil traps. Why have we not actually looked at this shale before for this? Because fluids don't flow very readily through shales. We call that permeability, the ability of fluids to flow through rock. A little bit more of that in a minute. But I went to speak in Brussels, and I spoke to an NGO, and he says, well, we're happy enough with conventional oil and gas, but we're not happy with this unconventional oil and gas. To which I said, there's bugger all difference. The shales and coals, you see in the lower, are the source. Some of it escapes into reservoirs, like that sandstone. Okay? It's the same gas. On the left, George Clooney, conventional. On the right is Boy George, unconventional. Yes, you can tell the difference, at least I can. On the left is unconventional gas. On the right is conventional gas. You can't tell the difference. They are the same, right? So anybody who makes a significant distinction between the two, Caroline Lucas said, we're happy with this natural gas, but we don't want any of this shale gas, which is one of those stupid statements I've ever heard made. Okay, I'm going to wander a bit. So, the gas we've been getting for years is mostly out of red sandstone like this. The Sherwood sandstone, the Bunker sandstone that we get from Europe. It's porous. Those pores are connected. It's like a sponge. Fluids can flow in, fluids can flow out. That includes water, includes oil, includes gas. It has a high porosity, it's spongy, it has high permeability, those pores are connected. All of the gas sits in those spongy bits. On the left is coal. Coal contains 10 times as much gas as the equivalent volume of rock, but it's held in a liquid-like way by something called the Leonard-Jones potential. There's only one person who knows anything about Leonard-Jones, who was a founding professor of physics at the University in Cambridge. It's a way where it's taken into molecular structure. Between those two are two things: tight gas, which is sandstone, low permeability, and shales. And both of these are quite reluctant to give up their gas. But there's lots of it. Just for comparison, people think this shale is a magical rock. If you want to get in your car and come with me and drive 15 miles, we'll go to the Vale of Bowland, we'll climb to Clitheroe, and we'll see it. It's exposed, its surface. Pendle Hill, Vale, it's not called the Vale of Bowland for nothing. Further south, we have natural oil seeps in Formby. But just to compare, the US shale market, based on the Marcellus shale there, okay, that's only 300 meters thick. Polish shales are only 150 meters thick. Francis may correct me, but in actual fact, the Bowland shale in many places is more than 1 kilometer thick. It's probably 3 times thicker than the Marcellus and the Barnett in the US, which is good. Probably not as laterally extensive, but there's a lot of it. We'll talk about amounts of gas in a minute. So the methane in those shales is stored in 2 ways, one of which is absorbed into the structure a bit like coal, and a little bit of it is held in fractures, because these shales actually have natural fractures. And the trick is to get it out. So they're really very appealing. In any other oil prospect, we actually have to find a reservoir, we actually have to have a seal to keep the gas in, and we have to have gas. Shale is an oven-ready chicken. It's all there. The source, the reservoir, and the seal are integral to that shale. It's a self-contained system. Okay, permeability. This is actually very important. These numbers on the bottom are in a unit called the Darcy, or the millidarcy. Darcy of the oil foundation history. On the right, we have rocks which have relatively good ability of fluid fluid. 100 millidarcy. This is a log scale, right? Going to the left, it gets harder and harder to get the gas out. Once we get down here, we're 0.0001 millidarcies, which is 0.1 microdarcy. Right? You'll excuse this. Shales are tighter than a canard's orifice, or as we're in the northwest, tighter than a duck's arse. Okay? So it's not that easy to get them out. Just a little bit of politics before the politicians come in. Crimea is a piece of political opportunism by Putin. The real issue is that the pipelines from the Stockman and Yamal fields, many of them run through the Ukraine. Right? That's why this started. This started in 2009 when Putin cut off gas to the Ukraine. That is still one of the principal issues. Crimea crept in on the back. But European gas, a lot of it comes from Siberia. And we pretend it doesn't come to the UK, but gas comes out of the pipelines in Belgium. Gas goes into the pipelines from Siberia. Gas is what's known as a fungible quantity. One molecule of gas is considered to be the same as another. So if we push it in from Siberia and it comes out in Belgium, that's still, if you like, equivalent to being supplied from Siberia. So watch this space in terms of gas supply. But all across Europe, we have these shales. I've just pointed out to you that all the way from Ireland to the Ukraine, this is an underestimate probably. Spain, Portugal, lots in France, Germany, Norway, the Baltic, all the way across into the Ukraine, where the Dnieper basin is 13 kilometers thick. Right? Shale gas is really very important politically. I've been twice to Abu Dhabi just before Christmas. If you don't think it's important, I can tell you the Gulf Coast states are actually bricking it because it means they will not be able to sell their gas into Western Europe. So we come to the northwest and the north. Okay, initially BGS didn't think there was much shale gas. They did a big study. This is only Yorkshire, Lancashire, bits of Staffordshire and a little bit of Cheshire, which is where I live. And the range is, on average, about 1,300 trillion cubic feet of resource. Now, I don't know if you know how much gas we use in the UK. Some of you probably do. We use about 3 to 3.5 trillion cubic feet per year. Now, how much can we get out? Bloody good question. We won't know yet. But if we say 10%, that's 130 trillion cubic feet, which is 40 years of gas supply for the whole UK. But of course, we'll use more gas, so I estimate between 25, 50, somewhere in that neck of the woods. But that's from the north of England. That's not from the rest of the UK. We might get out less, we might get out more. That's a great deal of gas. And that's led DEC to actually issue the map on the left, which is the areas which you will entertain PEDL licenses, Petroleum Exploration Development licenses. And a lot of the UK, south of Lancashire, is coloured blue. That's actually slightly misleading, and that led the newspapers to produce this very pretty map on the right, but in actual fact, that's not the whole story. It's the Goldilocks effect, right? This porridge is too hot, right? You don't get, your gas is gone and disappeared. This is too cold. You haven't cooked enough to make gas. This porridge shale is just right. You actually have to have the right temperature conditions. So this is probably a much more realistic picture of where shale gas is likely to be. Right here, Bonnie, Northumberland, beautiful county if you've never been that far, folks. Yorkshire, Cheshire, Gainsborough Trough, Widmerpool Trough, and of course, probably the Weald, and we're waiting on BGS to tell us how much resource there is there. Okay? But a lot of the UK still. So how do we get this gas out of here? Because it's reluctant to come out. Well, we have to produce artificial pathways, fractures. Okay? Now, how would you do that? Well, there's a variety of ways, but conventionally, I shouldn't use the word conventional, should I? I've just slagged it off. You need to actually pump high-pressure water into that formation because you've got 10,000 feet of rock weight above you, which means you have to put pressure which is higher than 10,000 feet of rock, which is probably around about 10,000 pounds per square inch. And if you do that, you can produce fractures in the shale above the fractures that are already there. But if you pump that water straight out, 10,000 feet of rock will actually close those fractures instantaneously. These fractures are like this. They're not like this.